Welcome back, listeners, to another exciting episode of Java Internals Crashcasts. I'm your host, Sheila, and I'm here with our resident Java expert, Victor. Today, we're diving into a fascinating topic that's been gaining a lot of traction in the Java world: reactive programming. We're starting a new chapter in our advanced topics season, and I can't wait to explore this with you all.
Thanks, Sheila. I'm thrilled to be here and discuss reactive programming. It's a paradigm that's revolutionizing how we think about and handle data flows and propagation of change in our applications.
Absolutely, Victor. Before we dive in, let's give our listeners a quick overview of what we'll be covering in this reactive programming chapter. We'll start with an introduction to reactive streams, then move on to the Flow API introduced in Java 9, and finally explore some popular reactive libraries like RxJava and Project Reactor. Today, we're focusing on the introduction to reactive streams.
That's right, Sheila. It's going to be an exciting journey through the reactive landscape. But before we begin, I think our listeners would benefit from a quick refresher on asynchronous programming. It's a prerequisite for understanding reactive streams.
Good point, Victor. Asynchronous programming is all about writing code that doesn't block the execution thread while waiting for operations to complete. Instead, it allows the program to continue running other tasks and handle the results of the operation when they become available. Now, to kick things off, I have a quiz question for our listeners. Are you ready?
I'm sure our listeners are on the edge of their seats, Sheila. Let's hear it.
All right, here goes. In a typical synchronous web application, what happens when the server receives more requests than it can handle simultaneously? A. It processes all requests sequentially. B. It rejects excess requests. Or C. It automatically becomes reactive and handles all requests efficiently.
Oh, that's an intriguing question, Sheila. It really makes you think about the limitations of traditional synchronous programming. Without giving away the answer, I can say that this question touches on one of the key motivations behind reactive programming. It highlights the challenges that modern applications face when dealing with high concurrency and data volume.
Exactly, Victor. Now, let's start our discussion on reactive streams. Can you give us a brief introduction to what reactive streams are and why they were created?
Certainly, Sheila. Reactive Streams is an initiative to provide a standard for asynchronous stream processing with non-blocking backpressure. It was created to address the challenges of handling streaming data in a scalable and efficient manner, especially in scenarios where data production can outpace consumption.
That's fascinating, Victor. Can you break down some of those terms for our listeners? What exactly do we mean by asynchronous stream processing and non-blocking backpressure?
Of course, Sheila. Asynchronous stream processing refers to handling a continuous flow of data elements over time without blocking. It's like a conveyor belt that keeps moving, processing items as they come. Non-blocking backpressure is a mechanism that allows the consumer of these data streams to signal the producer about how much data it can handle, preventing the consumer from being overwhelmed.
I see. So it's like a smart water management system where the flow can be adjusted based on the capacity of the pipes and reservoirs downstream.
That's an excellent analogy, Sheila. Just like in a water management system where you don't want to flood the downstream areas, in reactive streams, you don't want to overwhelm the consumers with more data than they can handle.
Got it. Now, what are the core principles of reactive programming that our listeners should know about?
Great question. The 4 core principles of reactive programming are responsive, resilient, elastic, and message-driven. Responsive means the system responds in a timely manner. Resilient refers to the system staying responsive in the face of failures. Elastic means the system stays responsive under varying workload. Lastly, message-driven indicates that the system relies on asynchronous message passing to establish boundaries between components.
Those principles sound crucial for modern applications. Can you give us an example of a real-world scenario where reactive programming shines?
Absolutely. Consider a real-time stock trading application. It needs to handle a massive influx of stock price updates, process them, and deliver insights to thousands of users simultaneously. Reactive programming allows such an application to efficiently manage this high-volume, high-velocity data stream without getting overwhelmed or becoming unresponsive.
That's a great example, Victor. It really illustrates the power of reactive programming. Now, I'm curious about potential pitfalls. Are there any common misunderstandings or challenges that developers face when adopting reactive programming?
Indeed, there are, Sheila. One common misconception is that reactive programming is always faster than traditional programming. While it can lead to more efficient resource utilization, it's not a silver bullet. Another challenge is the learning curve. The shift from imperative to reactive thinking can be significant for many developers.
Those are important points to keep in mind. As we wrap up this introduction, Victor, could you share a fun fact or interesting anecdote about reactive programming?
Sure, Sheila. Here's an interesting tidbit. The concept of reactive programming isn't new. It has its roots in the 1970s with the development of spreadsheets. In a spreadsheet, when you change a cell's value, all dependent cells automatically update. This is essentially a form of reactive programming.
That's fascinating, Victor. It's amazing to see how long-standing concepts evolve and find new applications. Now, let's circle back to our quiz question. Victor, would you like to reveal the answer?
Certainly, Sheila. The correct answer is B. It rejects excess requests. In a typical synchronous web application, when the server receives more requests than it can handle simultaneously, it will reject the excess requests. This is one of the limitations that reactive programming aims to address, allowing for more efficient handling of concurrent requests.
Thank you, Victor. To summarize today's episode, we've introduced Reactive Streams as a standard for asynchronous stream processing with non-blocking backpressure. We've discussed its core principles of being responsive, resilient, elastic, and message-driven. We've also touched on real-world applications and potential challenges in adopting reactive programming.
That's a great summary, Sheila. In our next episode, we'll delve deeper into the Flow API introduced in Java 9, which provides a standard implementation of reactive streams in Java.
I'm looking forward to it, Victor. And to our listeners, thank you for tuning in to Java Internal's Crashcasts. If you've enjoyed this episode, please subscribe to our podcast and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java internals. Until next time, keep coding and stay reactive.